right, bad gunner. 5.5. Here we go. So let's review a little bit of Algebra 2 and pre-calc before we get into the calculus of it. All right, so a to the power of 0. Anything to the power of 0 is? 1. All right, if I have exponents and I have multiplication going on, what happens to those exponents? They're adding. All right, if I have division with the same bases, what happens to those exponents? They subtract. All right, if I have a power to a power, what happens to those powers? They multiply. All right, so those things we still need to be aware of. All right, here we go. I need a reader. Thank you so much. Miller time, go.
The half-life of a carbon-14 is about 5,715 years. A sample contains 1 gram of carbon-14. How much will be present in 10,000 years?
All right, let's just build a model. So now we have y equals, how much did we start with? 1. So we started with 1 gram. And then it's a half-life. So this one's 5,715 years. So every 5,715 years, it's going to half. All right, so it's going to half each time that period is occurring. And so the period to occur is that 5,715 years. So we're going to just put our time over that time period. And so that would be the model of that equation represented there. So what do we need to do? Substitute in what? 10,000 in for t. So we'd have y is equal to 1 times 1/2 to the power of 10,000 over 5,715. And we put that into our handy dandy calculator. How many do we round to? 4 decimals. And we end up with
0.2973 grams.
Fantastic. All right, let's keep moving. So again, we're going to review a little bit of pre-calc or algebra 2. If we have a log base a of x, we could do natural log of x over natural log of a to represent that. That's the change of base, remember? The log of, log base thing. So that's the way we could deal with that. And then we ended up doing this log base a of b is equal to c. And how did we solve a log when we have log base a of b equals c? A to the c equals b. So again, all that's algebra 2 pre-calc stuff. So if I have log base a of 1, well, how would I solve a log? A to the c is equal to b. Well, what does c have to end up being? 0, because a to the power of 0 is 1. All right? And then if I have log base a of x, y, how do I break this up? If I have multiplication going on, how do I break that up and expand it? I add them. All right? I add them. So a lot of the times we're going to have this big nasty log. And we need to do what to it? Break it up into little logs. Now, if they were natural logs, how would we do it? We'd drop them naturally. Now, we're going to be dealing with other stuff very soon. If I have log base a of x to the power of n, this is that power property. What could I do with that n? I bring it out front. All right, on a few of your homework questions, I'd highly recommend you do that before your life gets crappy. All right, this next one, I have log base a of x over y. So that's division going on. So what would that be? That would be subtraction. All right, so all those properties we still need to know. Pretty good in the hood? All right, so let's do a little bit of algebra 2 again. We have 3 to the power of x is equal to 1 over 81. So first of all, what happened to this exponent? Is it positive or negative?
Negative.
It's negative. Why?
Because it's a fraction.
Because it went to the bottom. All right, and so
-4.
x to the power of what? -4. All right, so x equals -4. All right, so this next one, I have log base 2 of x is equal to -4. So, again, how do I solve a log? A to the c equals b. So now I'd have 2 to the power of -4 is equal to x. So
1/16.
I'd have x is equal to 1/16. All right, pretty good in the hood? All right, we moving. So now we're going to get into some calculus. All right, so let's get out our note card. All right, so if we have a function a to the power of x, some number to the power of x, this is where you're starting to add things. All right, so we're all the way on the right side. So if we have a function a to the power of x, the derivative is natural log a to the power of x, where a is just a number, it's a constant. If we were to go backwards, we're going to get to this later on in this lesson. So big F of x is equal to 1 over natural log a to the x plus c. All right. And then let's go ahead and write our other one. So if f of x is equal to log base a of x, where a is just a number, f prime of x would equal 1 over natural log a, and then it's still over x. All right, so x is still in the denominator right there. Let's do some examples. So we have y equals 2 to the power of x. So let's just look at our note card. How would I tell that I'm taking a derivative? What would be the derivative notation? Dy dx. We don't have an f. All right. So dy dx is equal to natural log of 2 times 2 to the power of x. All right, let's look at this next one. I have y equals 2 to the power of 3x now. So how do I tell me that I'm taking a derivative? Dy dx is equal to natural log of 2, and then 2 to the power of 3x. What rule can we never forget, though? The chain rule. So what's going to pop out? 3. Full 3. All right. So now I have a 3 natural log of 2 times 2 to the power of 3x. Now, honestly, this is fine by me. If it's a free response, this is good. This is all good. However, on multiple choice, AP will not have that answer sometimes. What could they do? The 3 would be a what? An exponent. So what they're going to say is they're going to say natural log of what? 8. And then 2 to the power of 3x. You see how that worked?
Yes.
All right. That's what they're going to say the derivative is. And it's not wrong. It's just they used a little bit of algebra 2 or pre-calc. All right, let's look at this next one. I have log base 10 of cosine x. So again, how do I say I'm taking a derivative of it?
Dy dx.
All right. So what goes in the denominator?
Natural log 10.
Natural log of 10. And then my x is just what?
This is big cosine x there.
Just cosine x. All right. But is that it?
No.
No. What pops out?
Negative sign.
Negative sine x. All right. So a negative sine x goes up top by the chain rule. Now, a lot of the times that might not be the answer that they give. What could they do? They'd have a negative tangent up top. All right. They'll have a negative tangent x over natural log of 10. See how that worked? All right, I want a freestyle one. I'm going to say log base, 3 of
I want to see something here. Click.
the cube root of x squared minus 1. Why not? And I'm going to call this h of x. All right? All right, so on this one, what would I highly recommend you do first? Break it up a little bit. What could I bring out? A 1/3. And so now I'm going to bring out a 1/3, and then I have log base 3 of x squared minus 1. All right. Now, I can't really break it up any more than that. If I had multiplication going on, what would I really do again? I'd add them. However, I can't break this one up anymore. I'm pretty much ready to go here. So now I'd have a 1 h prime. I'd have a 1 over 3. And then what? Natural log of 3. And then x squared minus 1. And then what pops up? A 2x. All right. They might say this is like natural log of 27, or they'd leave it like that. Does that make sense? All right, let's keep moving. So now we're going to integrate. All right, so again, all I want you to do is look at your note card. It's really what I want you to do right now. Okay, towards the end of the year, we will have to have these memorized, but right now, I just want you to use your note card. So let's antiderive 2 to the power of x. So let's look at our note card. What's my antiderivative? I'd have 1 over natural log of 2. And then what? 2 to the power of x. And then plus c. All right. All right, I want to freestyle one. So I'm going to say it's the integral of 3 to the power of 2x dx. All right. So now I have the integral of 3 to the power of 2x dx. Well, what would be my u? 2x. So what would be my du? 2 dx, right? So what needs to be brought out front? A 1/2. So now I have a 1/2. And then I would have what on the bottom? Natural log of 3. And then what else?
Wait.
I want you to look at your note card. And then what else? And then I'd have 3 to the 2x. And then plus c. All right. Pretty good? All right. Fantastic. All right. So I want to look at some things from the past a little bit. If we remember our power rule was a variable to a number. Remember? And so what did we do when we took a derivative with a variable to a number? We brought the number down, and then what did we do? We subtracted 1. If we were to take a derivative of just a number, what would that be? That would be 0, right? And then we did like a to the x, so a number to a variable. And then we just did those. So I want to look at these. So on this first example, I need to derive e to the power of e. So what would the derivative of e to the power of e be? It's 0. Why? It's just a number. All right? 2.718 to the power of 2.718. All right? It's just a number. All right? I don't know what the number is. 25? I don't know what it is. But derivative of that is 0.
It's not be something closer to 4 or 5. It's somewhere between. For what reason?
This next one, I have the derivative of e to the power of x. So what's the derivative of e to the power of x? E to the power of x. There it is. All right. That was that special one. Okay, it's one of the easiest ones. All right, this next one, I have x to the power of e. So a variable to a power of a number.
Wait.
So what do we need to do?
Ex.
E to the power of x, or e times x, and then to the power of what?
E
minus 1. Exactly. All right, we subtracted that power. And then right before break, we did this one. We had y equals x to the power of x. It's not a power rule. It's not an a to the x. So what did we have to do here? We had to natural log both sides first. All right, so we had to natural log both sides to bring it down. So now we have x natural log x. Then we take a derivative. So what's the derivative of natural log y? 1 over y. And then what? dy dx. And then what rule is happening over here now? The product rule. So what's the derivative of the first? 1. So now I have 1 times natural log x plus the derivative of my second. What's the derivative of my second? Times x.
Wait.
And so
That's like a 7 to 1.
That does. So now we have natural log of x plus 1 over there. And then what do we need to multiply that one to get to dy dx? We need to multiply by y, but what's y? X to the x is y. All right. Remember doing that before break? All right. For you. So page 368, numbers 41 through 81 odd, and 83 through 86. Now, most of those are what kind of problems? Odd problems. So what could you do? Check them. All right.